Now in this video I'll show you go through a couple more examples of how to solve one-step equations. In this case focusing on addition and subtraction. Now the rules were from last video, they were to have the pronumeral, so the letter, to be by itself, and it can be by itself either on the left hand or the right hand side. Right? So that's what we're trying to have by the end. We're trying to have the pronumeral, the letter, be by itself on either side. Now how to do that? Remember, we want to find the inverse, the opposite of what we're trying to move. So if we're trying to move plus 3, well, what's the opposite of plus? It's minus. So we'll do minus 3 to move that plus 3. And we'll talk about those examples in a second. Now that's what we have to do, is the inverse of what we're trying to move, but important to make sure to perform that inverse on both sides of the equation. Not just one side, but both sides of the equation. I'll quickly show you why it's possible to do the inverse, and then thereby it moves it away from that side. So for example, let's say I've got plus 3 on one side, and I want to move that plus 3 away. I want to remove it, and how do I move it? Well, if I'm starting at plus 3, if I want to remove it, what that means is I want to get to 0. Right? Because if I'm at 0, then there's nothing left. So I start with plus 3, I want to be at 0, so what can I do? Well, if I start at plus 3, if I end up taking away 3, so I have minus 3 from that side, so that's minus 3. Well, what is plus 3 minus 3? Well, that will equal 0, so that cancels out. Right? Now, it's actually interesting, it's on the same way if it works the other way around. If I start at minus 3, right, so I'm right here, I'm starting at minus 3. How could I remove minus 3? So that means at the end I want to be at 0. Well, if I add 3, so 1 plus 1 plus 2 plus 3, so I start at minus 3, then I've added 3. Well, I end up being at 0 again, right? So plus 3 minus 3, or minus 3 plus 3, they both cancel out and we're left with nothing. And that's what we'll try to do, because we're trying to get the pronumeral to be by itself. I'll go for quite a few examples to show how that works, but we'll start with this one. Right, so it's our first example over here. X plus 3 equals 10. Remember, the idea behind this is we want to get that pronumeral, so in this case the x, to be by itself. At the moment on the left hand side, so this is on the left hand side, we have x and plus 3, and we're going to try to move that plus 3. Now the rules were, remember, find the inverse. So what's the inverse of plus 3? Remember, inverse is the opposite. Well, the opposite would be minus 3. So we're going to do plus 3, and we're going to take the inverse. We're going to take minus 3 from that side. But the other rule was perform the inverse on both sides of the equation. So we're going to have to do minus 3 on both sides. Now remember, why do we do minus 3? Well, what is plus 3 minus 3? That's 0, that cancels out, and that's why we've done it. We want to have nothing left on one side. So now, or except for x. So now we've just left x on this left hand side, and we've left 10 minus 3, which is 7 on the right hand side. And that's your answer. And that's all we're trying to do. We're trying to solve the equation by having x be by itself on one side. Next example. 5 equals y plus 4. Remember the rule or the idea behind this, the aim was to get y to be by itself. At the moment it's not by itself, it has a plus 4 over here. So we're going to try to remove that plus 4. And how do we do that? Remember the rule was the opposite. Now in this case it's all on the right hand side, not on the left hand side, but it doesn't matter. As long as we get it to be by itself on one side, doesn't matter left hand side or right hand side, we'd be just fine. So how do we move the plus 4? We'll do the opposite. We'll do minus 4 to both sides. Why? Because plus 4 minus 4 cancels out. Now we're left with, on the right hand side in this case, we're left with what? We're left with just y. And we're left with, well, what's 5 minus 4? That's 1. That would be our answer to that problem, right? So y equals 1. So see, the difference here is only that we have it now on the right hand side, but it doesn't matter if it's on the right hand side or left hand side, as long as the pronumeral, the letter, is by itself. Now what's the difference for the next one? So we've done the second one already now. We're up to the third one. So here we have 9 plus x equals 12. So it's just rearranged in a different format. But that 9, remember there's no minus in front, so if there's no minus in front, that means it's plus 9. So we're doing the same thing again as beforehand. We're trying to get the x to be by itself. Now we're going to try to remove the 9. And the 9 in this case is plus 9. So what do? Well, do we do minus 9 on both sides? That 9 minus 9 is nothing, cancels out, and we're left with, well, we were left with x on the left hand side, and we're left with 12 minus 9, 3 on the right hand side. And that will be your answer, right? So in this case, your answer is x equals 3. And those are all the examples for how to do it when it comes to, if we're talking about addition, and subtraction is actually the same way. So let's have a look at the examples over here. X minus 6 equals 12. Now remember, we start a negative number, and that's what we have. We have negative 6 on the left hand side. We are going to do exactly the same thing. We want to have the polynomial be by itself, so x by itself. At the moment there's negative 6 over here. Rule is find the opposite first. So what was the opposite of negative 6? Well, that would have been just plus 6. We do that to both sides. Now remember, negative 6 plus 6 is 0, just like over here, negative 3 plus 3 is equal to 0. So that means that cancels out. And we're left with, on the left hand side, just x. And on the right hand side, we're left with 12 plus 6 is 18. And that would be your answer. Right, so it works exactly the same way as with the plus, except for we'll do in this case, we start with minus, but do plus to both sides. Right, so over here, 10 equals y minus 10. Remember, it doesn't matter if we get it to be by itself on the left hand or right hand side. So over here, we want to get the y be by itself. At the moment, we have minus 10 on that side. So we'll do the opposite. We'll do plus 10 to both sides. And we're left with minus 10 plus 10. Well, that cancels out. That's gone. And we're left with just y, in this case, on the right hand side. Equals, well, what's 10 plus 10? That's 20. So that would be our answer. So that's the answer for second example for subtraction. Now with the next example, we're at minus 5 plus x equals 6. And with the minus 5 out here in front, but the rules are still, what we're trying to do is still the same. We're trying to get x to be by itself. There's minus 5 over here on the left hand side. Well, what do? We do plus 5 to both sides. And why is that the case? Well, what's minus 5 plus 5? That cancels out. It's left at 0. And now we're left with just x on the left hand side. And we're left with 6 plus 5, which is 11 on the right hand side. And that would be your answer. X equals 11. Alright, so the rules are, well, the aim is to have the polynomial be by itself, either left hand side or right hand side. How do we do that? We find the inverse of what we're trying to move. So here, if we're trying to move plus 3, then we'll do minus 3 to both sides. And again, we have to do both sides because an equation is equal on both sides. So we do it to one side, we have to do the same thing to the other side. But by the end, we want to have just one answer. So x equals something, y equals something, or whatever else is our polynomial of choice.